Hey guys, for this video we'll be looking at inserting records into tables that have relationships. So in previous videos we would have already inserted some records into some of our tables, and I discussed the atomic tables versus the ones that have dependencies, or parent tables versus child tables. That's another expression you'll hear in database nomenclature or database terminology. So we have courses, and we created some, and I'm just right clicking the tables and going to edit top 200 because now we're supposed to be comfortable with our editor. And we should be proficient enough in SQL to be doing our select statements if we want to see what's there. But for expediency, for speed, I'm just going to use the editor for most of these operations. So we didn't put in any teachers, so I'm just going to go ahead and insert about 3 teachers. All right, so I've added 3 teachers, and note because I use the date as opposed to date time, we don't see a timestamp on the date joined column. So that's what date looks like. I think we use date of birth had the timestamp, right? So I'm just showing you the different data types. So once again, date may not be available in previous versions of SQL, and in your corporation, you may not be using the latest one. So I'm just showing you all of the different scenarios so you can act according to your context. So we have 3 teachers, we have a few students, and we have a few courses. Now, what we don't have are enrollments. We don't have any teacher actively teaching any student through any course. All right, so that is why we created the enrollments table, so we could actually bind them together through relationships. So I'm just going to edit the top 200, and then you notice, based on our previous design and based on what's on the screen now, all that is allowed in these columns are integer values. They're just IDs, right? And Gradewell, we had a string value allowed for this, but these are only willing to accept integer values. So what this means is when we have a table with relationships and we set up the relationship to be on the primary key columns and the IDs have to match and they're all integers, your primary key, your foreign key column is always just going to have the referencing ID to the detailed record. And that was discussed in the first video of this series. So once again, we're not repeating the teacher's details every time there's an enrollment, because if John is teaching multiple courses, then we don't need to see John every time he's teaching a course. We're seeing John throughout the database, right? That would lead to messy data. And that's a part of normalization where we're cutting out all of that repetition. So if you realize you're in a situation where the details of something is going to be repeated more than once, then you probably need to look at creating another table to have that detailed information once, and then what you do is only repeat the referencing ID to that detailed information. So that is how normalization works. You'll see things about first normal form, second normal form, third normal form. To me, those normal forms are important when you're looking at already messy data and trying to fix it. But for me, I skip past the normal forms and I just say design the database in a normalized form from day one. If you see repeating details, put them in a table for themselves so they only appear once, and then repeat the ID associated with whatever it is. So that is what we're doing here. So instead of repeating the teacher's details, because John is currently going to be teaching the top 3 courses, HTML, SQL, and PHP, we want to just repeat his ID. So we'll associate the ID 2 with the courses 1, 2, and 3. All right. And I'm going to give him 1 student for each. So Jody McIntosh is currently in all 3 of those courses being taught by John. All right. And the reason I'm doing that is the fact that we have IDs, we can't insert any. Oh, I did allow null on my design. So I'll just pop on over to the design quickly. And I did allow null, which means that we don't have to enter all of the values. The only thing that is really absolutely necessary is the ID. So we can do that. So as it stands, we have given John with ID 2 the course. Let me just close one of these. The course is HTML, SQL, and PHP. And let's just say he has no students at the moment. So we're going to associate teacher ID 2, who is John, with course ID 1. I can press enter and see it saves it, so no student. He's also teaching course ID 2, and he's also teaching course ID 3. All right. Now, this kind of looks stupid. I can appreciate that, because then you're moving away from clearly seeing who teacher ID 2, John, and you're now just looking at 2s and 3s and numbers. All right. Now, from a human perspective, it may look foolish because we prefer to see letters than numbers, but the computers thrive more on numbers. So it's actually more efficient to get this number and find all the details in somewhere else than to have those details repeating every time. And that will actually lead to a slower database and a slower application overall, because I figure you're building your database here to use in an application. And that's point number one. Point number two is that because you're using your database in an application, filling out these IDs would be much easier from an application standpoint. If you're not an app developer just yet, that's fine, but I'll just give a high level overview. But do remember that when you'd be filling out and creating these associations, you would kind of be dynamically associating the controls in your app with the values from the ID columns. And so you can pass that into your database quite easily through code, and you wouldn't have to necessarily manually come in here and actually be writing 2s and 3s and 1s and 2s, all right? But because we're learning database in the context of database design, I'm just showing you exactly how this data goes into the database. So back to what we're doing, we actually have associated John with courses 1, 2, and 3. So if I look at this enrollment record, I'll see John teaching course 1, which is HTML. I'll see John also teaching course 2, which is SQL, and he's also teaching course 3, which is PHP. And he has given no grades because, well, quite frankly, he has no students. So I did say that Jody is actually taking all 3 of those courses. So now that we know Jody has enrolled because she looked on the timetable and saw that John is teaching these, or these are the 3 courses being offered by John. And once again, you could have put on the semester details and whatever, whenever, and even the campus. It's your database. You can do the design. Now Jody is interested, and Jody is going to click enroll. So she goes onto the app, the school management app, school management system, and she enrolls in these 3 courses, all being taught by John. So now her ID, which is 3, gets associated with John and each course. So this is what I was saying about repetition. Imagine if we had John, Jody, and HTML, PHP, and SQL. And it would be very tedious when it balloons into more than one, and then you have to track all of the Johns and all of the Jodys. And we can just say, which student is doing this with John? And we just look for a student ID 3, and we see everything about Jody in one place. All right. So it could get messed up if it's in multiple places. So we try to keep that repeating data one place. All right. Now, here's another scenario. Patroy has decided to also do SQL and PHP. He's not doing HTML. He's only doing SQL and PHP. Now, here's the beauty of using our relationships. We can actually repeat this. So we know John is teaching that course. So we can just put in John twice, and I'm just doing this. So we know John is teaching that. And we did say the student in question would be Patroy. His ID is 6. So we just put in 6 and 6. Oh, I'm sorry. Something is going wrong here. Let me do that over. All right, so we're associating Patroy with John once more. So change that out. And he's doing courses 1 and 3 only. All right, so here we see teacher ID 2. So we see John is teaching all these courses, and he has 2 students so far in these courses. So now we can track directly if we were to pull all of the HTML students that John is teaching. We could just look at all of the course ID 1 and teacher ID 2, and then we'll see all of the student IDs coming back in that query. All right. And we'll get into that eventually. We're just looking at inserting and we will look at how we go about pulling reports, because I mean, obviously we're only using numbers, so it will take a bit more caressing of the data to actually accomplish viewing certain things. So I'm just going to use this time and I'm just going to fill out some more data. I'm going to put in about 20 records of enrollments, and we'll reconvene. All right, so I said 20 and I only did 11. I'm sorry. It's kind of tedious and annoying, and I'm sure you're experiencing the same thing. But I don't know if you've done this as yet, but I'm just going to display something to you. So do remember that by setting up the relationship, we would have enforced certain constraints. We shouldn't be able to put in a teacher ID that does not exist in our teacher table. So if in enrollments, I try to put in the value 10, and then let's just fill out the rest and then move on to the next line, then it will tell me nothing happened. It was not committed. And the error message is that it conflicted with the foreign key constraint. The conflict, so it's not really telling you, oh, there's no value 10 in the parent table, but that is essentially what is happening. The constraint is that no teacher ID value can exist in our relationship, in our foreign key column, that does not exist in the primary key column of the primary key table. All right, so that is what that brings about. So if we were repeating details and saying John all the time, then somebody could come in and say, oh, spell his name Juan, because they're trying to be cute or funny or something. And then that would lead to some data integrity, because then we would be wondering, who is this Juan? Where did Juan come from? And then we really wouldn't know who this teacher was. So by using foreign keys and relationship, we're enforcing certain data integrity across the board to ensure that no value goes in without it being vetted by a second source, so to speak. So I can just change this value to 1 and press enter. And when I'm pressing enter, it's telling me another error, but then this time it's with the students, because I don't have a student with ID 2. All right, I deleted that one. So I'm just going to change that ID to 12. And voila. So I have a rich mix of students and teachers, and it all looks confusing by this point. If I went all the way up, it would have been even more confusing, and rightfully so. So, I mean, inserting isn't the cutest process and procedure, and even looking at it, it's not very intuitive. At least it's not as intuitive as looking at the teacher and the students and the courses. So what we'll do next is look at how we can go about pulling meaningful data from this table when it looks like this.